Hello everyone, I welcome you all to this class. You are highly welcome to this class. In this class, we will be stating this important theorem, the mean value theorem, and we will show that a certain function satisfies this mean value theorem. Let's state this mean value theorem. Suppose you have a function f, and that function is continuous on a closed and bounded interval a comma b, and the function is differentiable on the open interval, then there exists at least one point c inside the open interval such that the derivative of the function at that point c is equals to f of b minus f of a divided by b minus a. So this is what this mean value theorem states. So let's look at this example given here. Show that the function f of x, which equals 3x raised to power 2 minus 1, satisfies the hypothesis of the mean value theorem on this closed and bounded interval 0, 1. Now the function, for this function to satisfy this mean value theorem, the function must be what? Continuous. The function must be continuous. Now the function we have here is what? A polynomial function. Whenever a polynomial function is given to you, polynomial function is always continuous everywhere on the real line, and this closed and bounded interval is just a subset of the real numbers. So since polynomials are continuous everywhere on the real line, so it must be continuous on this subset. And if you check it, if you look at it in an elementary way, any number you pick from 0 to 1, any number at all you pick from 0 to 1, and substitute for x and replace it with x, what you will get will always be a real number. You will not get infinity or undefined, right? So let's make that statement. So I've written this, what I just said down, I've written it down here. So this function, which is f of x, which equals 3x raised to power 2 minus 1, is continuous on this closed and bounded interval. My reason is that it's a what? A polynomial. It's a polynomial. Now, the next thing you have to check is whether the function is differentiable on the open interval. What is the open interval of this? Open interval 0, 1, right? So let's check whether it's, let's differentiate the function. f prime of x. So what is the derivative of this function? If you differentiate this function, differentiate 3x squared, you have what? You bring down the power, right? 2, you have 2 multiplying 3x. Then remove 1 from 2. That's 2 minus 1, right? So this will give us 6x raised to power 1, which is the same thing as 6x. Now, look at this derivative. The derivative we got is what? A polynomial, right? It's a polynomial. So the derivative is also what? Continuous on this open interval, because clearly what we got is a polynomial. And if you check it in elementary way, any number you pick between 0 and 1 and substitute for x, you always get what? Real numbers. You will not get infinity or undefined expression, right? So this derivative is continuous on this open interval, which we can say that the derivative exists, right? The derivative exists on the open interval. So what I've just written down here is what I said earlier. Then the next thing you have to do is to get that point c such that the derivative of the function at the point c is equals to f at b minus f at a divided by b minus a, right? Now let's get f at b. Now f at b is equals to f at, look at the closed and bounded interval we have. B is the end point of the closed and bounded interval. So f at b is the same thing as f at the last point. B is the last point. So f at b is the same thing as f at the last point, which is f at 1. The last point of this is 1. So we substitute 1 in this we substitute, replace x with 1. So you'll be having this will be equals to 3 into 1 squared minus 1. So I've replaced x with 1 here. So this will be equals to 3 minus 1, and this equals what? 2. Right? Then f at A. A is the first point. What is the first point in this closed and bounded interval? 0. So f at A is written as f at 0, and you come to your function and replace x with 0. So you have this is equals to 3 times 0 squared minus 1, and this is 0 minus 1, and this is negative 1. Right? So we got this. This is negative 1. Then let's evaluate this expression. Let's get this expression. So we have f prime at c, right? F prime at c. Let's come to your derivative, replace x with c, right? So replace x with c. So f prime at c is equal to what? You replace x with c here, is equal to what? Cc, isn't it? F prime at c is cc, and by the mean value theorem, we are going to equate it with this, right? What is f at b? F at b is what? 2. You have 2 minus, you put negative sign. What is f at a? Negative 1. Negative 1 divided by, what is b? The end point, the last point, 1, minus what is a? The first point, 0. So I have done b minus a, the last point minus the first point. So this implies what? This implies that f prime at c, which is cc, this implies that cc is equal to negative 1 will give you what? Positive 1, right? So you will be having 2 plus 1 divided by 1 minus 0 is what? 1, right? This implies that cc is equal to 2 plus 1 will give you 3, divided by 1 we have 3. So you divide both the two sides by what? Coefficient of c. So this implies 6c divided by 6 is equals to 3 divided by what? 6. 6 gets cancelled. Then what you have is that c is equals to 3 divided by 6. 3 can divide 3, you have 1. 3 can divide 6, you have 2. So you have half, and this half is inside the open interval 0, 1. Right? Half is 0.5. 0.5 is a number inside this, is a number between 0 and 1, right? So therefore, the mean value theorem is what? Satisfied. So clearly the function we have satisfies the hypothesis of the mean value theorem on this closed and bounded interval 0, 1. So thank you so much for being part of this class. I'm expecting you in our upcoming class. Bye.